In this video, I'm going to go over how we use the kinematic equations in physics to analyze the one-dimensional horizontal motion of objects. And these are the four kinematics equations. Sometimes I like to call them the big four. Now, in a moment, I am going to over a couple examples how we use the kinematic weight, but there are a few things I want to say briefly. First of all important, remember that these equations are usual. We have constant acceleration when the acceleration is staying the same now. That means that the velocity will be either increasing or decreasing, but the acceleration will be staying the same. Constant acceleration. Now you will notice we have four equations, and in these four equations we have five different variables. These are the initial velocity, the final velocity, their change in position, the acceleration, and the time. And we can use these equations to solve for any of these five variables. Now, in typical problems for kinematic equations, you will be given three of these variables and asked to solve for the first. You should notice that each of these equations has four variables in them. So if you are given three and asked to solve for the fourth, you can use for one of these equations. For example, this first equation has the change in position, the initial velocity, the final velocity, and the time. So if you are given three of these things, and you can for the fourth, that the way equations work. Now I want that in your textbook the initial velocity properly presented at the zero, at the velocity time is zero. I like put D because in your text also the final velocity properly just represented as V1, like to put VF. So therefore it and keep these two things separate much more easily. Of have and VF for the initial velocity and the final velocity. Okay, let's actually go through now, add a couple problems and see how we solve for the one-dimensional horizontal motion of object using the four kinematic equations. Now here the first problem. A car is waiting, stopping light, turn green when it does. Car accelerates from rest at rest of 5 to 5 meters per second square for time at 4.25 seconds, and we want to determine how far the car is going to travel now. I think the most important things to do, and the first things you should always do when you have this problem, is write down all five the variables that would be the initial velocity, the change in position, acceleration, and the time. Write all five of them and down, and then write in full what you have been given and what you are trying to solve for the knowns and the unknowns. Let's read the problem carefully and fill those things in it. Say car waiting at stoplight. When it does accelerates from rest, tells you that starts at rest and that the initial velocity 0 meters per second. Then we are given the acceleration, then we are given the time, or asked to solve for the change in position or the distance, and we are not given, and we are not going to solve for the final velocity. So therefore you can see, as I said the previous slide, we are given this thing, the initial velocity, the acceleration, the time. We are asked to solve for force, and therefore we can get out equation and figure and which equation we are going to use. Now how we do figure out, this is how we figure that out. We want to solve for the change in position, therefore the equation has to stay the minimum. the change in position in it. So let's look and see, does the first equation have to change in position? You don't have the change in position, so maybe I can use this equation. Well, the other things the equations have in it are the other three variables that we have been given. So let's see, do we know the initial velocity? We do. We know the final velocity. We don't know the final velocity, therefore we can't use this equation. Let's look at the next equation. We are solving for the change in position. It has to have change in position. This equation does not, you cannot use the equation. The next equation, yes, it is had the change in position. We are looking for the change in position. It has that in that good sign. Now, do we know the other three variables in the equation? The initial velocity, yes. The time, yes. The accelerations, yes. And for course, this is time in the same as this time, and we know time, so therefore we know that we can use this equation. Now let's just check the last equation, and just for the heck of it, it has final velocity. We don't know the final velocity, therefore we can't use this equation. So we are going to use this third, and we are going to do the next slide. I bring formation and equation, and we are just going to fill value in solve for the change in position. Now the other things you should notice this problem and with this equation is that the initial velocity is 0 to the initial velocity times the time, therefore also going to be 0. So we can simplify this equation because the terms is 0. So therefore this equation becomes the change in position is equal to 1 over 2 square. Now how the acceleration, we know the time, and still the law students fill the value in 1/2 times 5.5 times 4.25 squared, and you get the car travel 49.7 meter during the 4.25 seconds. Okay, all we did was we wrote down all 5 variables, plug them right down to knows and the unknowns, figure out which equation we are going to use, plug the value and get the answer with the correct units. Let's try one more. Susie is riding a bicycle, and she is running 8.7 meters per second. Suddenly she being chased by the dogs. To get away, the accelerate at 1 meter per second for 10 seconds, and we want to know what is the half final speed. Once again, I am going to write down all 5 variables: initial velocity, final velocity, changing position, acceleration time. Now I am going to fill in the thing that I know and the thing that I don't know. All right, the first things I know is the initial velocity 8.7 second. The next know is the acceleration 1.5 meter per second square. The next thing I know is the time 10 seconds. We are trying to find the final velocity. We are not given to change in position, or not trying to solve for change position, and therefore now I can use my kinematic equation, because once again I have been given 1, 2, 3 over the variable going to stage for, and I need half equation that had the final velocity in it. So let's check the first equation. Does it have the final velocity? Going to use that equation. Next equation, do velocity. I am trying to solve the final velocity. Now have the final velocity. I know these other 3 final velocities. I do know that the acceleration. Yes, I do know that the time. Yes, I do know that. So therefore I know that I can use this second equation. Now Let's look at, just check the other two equations. Sometimes they are more one equation, sometimes one is easier than other. Now I am looking for the final velocity. The one does not have the final velocity. The one has the final velocity, but it also has the change position, which I do not know too. Therefore, I can't use the equation now. On the next slide, bring my information with me. I have my equation. Now I can fill in values because I know the initial velocity, that 8.7. I know this relation, and the times 8.7 plus 1.5 times 10 there, 1.5 times 10, 15 plus 8.7 gives us that her velocity, whose final velocity is 27 June 23.7 meters per second. As he tried to get away from jumpers, the dog. Okay, there you have it. I think it is pretty. We were over brief description of the equation used only for constant velocity. I told you, and you should always write down all 5 variables. Fill in what you know and what you do not know. Choose the right equation, plug the values in, give the answer with the correct units. Okay.